Hey Thinksters, and welcome to this video about the Python list append method. So how can you add more elements to a given list? Use the append method in Python. So in this tutorial I want to show you the most important usages and information about the Python append, list append method. And I will basically answer each and every question on the web which I could retrieve, and I hope that that I can give you some value with this. Okay, so let's start. Let's start with the list called L, and now we can use the append method on the list object itself and append an arbitrary element. Okay, so like the element 42 to the list, and let's print the list. You see that the list consists of one element, which is 42. Good. Then we also can have we can add more elements. Oops, L does not exist. Okay, so now we have appended another element, and you see that the element is appended at the end of the position, at the end of the list. Okay, so therefore, I mean, if we start with an empty list, we use one append operation. We obtain the list with one element for the two. If we add another element, that the new element will be at the last position in the list. Okay, so we will always add one element to the list, appending it to the last position on the list. And so this is the basic syntax. The append function, as you see, takes only one argument. There's also no additional argument or optional argument or so it's only one argument. And okay, so let's have a quick puzzle. So say we have a list with 3 elements, and now we call the function append on it. So what happens now if you run this function? So what is the value in our nums? So for example, how many elements are in our nums list? So can you figure it out? So basically here we are using slicing. So we create a copy of the list nums, and we append this to our existing list nums. Okay, so we append a copy of our list nums to our existing list. How many elements are there? Initially we have 3 elements. After the append operations, how many elements do we have? Yeah, we have 4 elements. So it's a bit a trick question. I expect that some people assume that the answer is 6 elements, because we add 3 elements to a list with 3 elements, which results in 6 elements. But this is not the case actually. Why? Because if you print the list, you see that it simply appends the whole list to the existing list nums. Okay, so we have like an existing, we have a list nums, and we add a copy of this list to our list, but every list can contain an arbitrary number of elements basically. So you can also add a whole list as an object to another list. So therefore we have like 4 elements, 3 integers and 1 list. Lists can be very heterogeneous, so there's no problem with that. Okay, so I hope you got this right. Otherwise, maybe the problem which you had was that you assumed that the append operation adds more and more elements to the list. But the append operation always, as a rule of thumb, always adds only one object to the list. Okay, so what happens if you want to add more elements to the list? Like, for example, in this case, if you want to add all elements of the nums list to the nums list again. So like we have then we would use the extend method. The extend method takes an iterable and adds all elements in this iterable to the list. Okay, so now we can basically create a copy of it and append all elements to the list. And if you print nums now, it contains those elements which have been previously already in the list, and basically all the elements again. So we have like 2 times the list. So the extend method allows you to add more elements to a list. The append method allows you to add only 1 element to the list. And so what happens if you want to like append a certain element at the beginning of the list, not at the end of the list? Then you need to use the insert method. The insert method takes 2 arguments. The first argument is the index, where we want to insert it, and it can be 0, for example, and the second element is the element which we want to insert. Okay, so let's print the nums array, and you see that the element 99 now appears at the beginning of the list. Okay, so therefore the insert method allows you to append stuff at the beginning of the list. Okay, let's create a new list. Okay, good. So the next question is, how can we add multiple or all elements to a list? And you have already seen it with the extend method. So the extend method takes an iterable. Iterable can be another list or a set or even other collection type that consists of many arguments where we can iterate over it. Therefore, it's an iterable. It simply adds all elements to the original list. So the extend method is able to do this. So then I have created a detailed article about the difference between the append and the extend method, also regarding performance. And an interesting experiment can be seen here. So I just take this experiment, which I have already discussed, and show you because it's interesting. Okay, let's open a code file. Here, so this experiment, we have two functions. We add lists by append, a list with n element, and we use the append operation. So initially we create an empty list, then we iterate over all elements from 0 to n excluded, and append them to the list. And now we have created a list with n elements. Now we do the same with extend and simply use the range function, which returns an iterable as an argument for the extend function, which is perfectly possible. And now we compare the runtime of both. Okay, so for different list sizes, on the x-axis we have different increasing list sizes, on the y-axis we have the runtime. And yeah, I won't go into the code, just execute this and show you the result. So we have to wait for a moment because it takes some time. Tastes good. Okay, now you see the interesting result. So the append method basically takes more than 2 times the runtime overhead. Okay, so we have like we have a 50% runtime improvement or more, even 60% runtime improvement by using the extend method. Both of them have basically linear runtime. So if you increase the number of elements n, we increase the runtime by proportionally to n. So we have linear runtime behavior, runtime complexity, but in both cases, in the append and extend operations. But calling the append operation multiple times is, of course, it has much more constant overhead because we have to compute a small operation again and again and again and again and again. While the extend method, just in one pass, in one batch, it adds all elements in the iterable to the list. There's minimal overhead. So if you want to add multiple elements to the list, then you should use the extend method, obviously. Good. Then let's get rid of this. So in the next part I want to discuss, so what is the difference between append and insert? And you have already seen that the insert method, it takes 2 arguments. The first argument is the index, the position where we want to insert an element, and the second is the element itself which we want to insert. And the append method is simply like a shortcut method for the insert method. Insert method is more powerful but also slower. So of course, I mean, we can insert something at the end, which would be then the exactly the same semantic as the append method, but it's much slower. So therefore, you should use the append method if you want to insert something at the end, and otherwise, yeah, use the extend method, the insert method. Okay, then how can we append at a certain? So how can we use the append function and create a new list, basically? Yeah. So we want to append an element to a list, but we don't want to append it to the new list, to the old list. We want to create a new list. Then in this case, so instead of, say we have list 1, 2, 3, and if we call now append 4, you see that the element 4 is at the end of the list. But now say we want to create a new list, like list 2, and by appending an element. And how could we do this? Basically, we simply use the old list, then we use the list concatenation operation plus, and add a new list with one element 5. Okay, now you can see list 2 has 5 elements, list 1 is not defined, the first list has 4 elements. Okay, so therefore the first list hasn't been changed by our operation. We have basically created a copy here. If you would have used the append method, then of course it would also have affected the original list lst. Then what is the time complexity of and memory complexity and efficiency of the append method? So just on a high level, the append method has time complexity 0. Okay, so therefore we adding one element to the list requires only a constant number of operations, no matter the size of the list. Why? Because I mean, even if the list has 1 million elements, we just go to the last element and change one pointer basically and append the element to the list. I can give you a quick example if you want. So okay, say we have this list. These are the elements in the list. And now we want to add a new element to the list. And we would simply go there, add a new element. And we don't care about all the baggage here. We don't care about the size of the list. We simply add the one element to the last element to the previous last element. Okay? So therefore, time complexity is linear, space is constant. Space complexity is also constant because the append method itself, it doesn't take any space apart from the one element which you want to add. And yeah, efficiency considerations, the append method has the same, the best asymptotic behavior you can expect for time complexity, for adding an element to a collection type, even if you use sets or binary trees. But if you add multiple elements to the list, then we can get some constant factor improvements, which you have already seen using the extend method rather than the append method. Yeah, the extend method takes an iterable as an argument, as you know, so you can add many arguments at once in a single batch. So this can lead to 50% or more performance improvements in many practical settings. So what if you want to append at a certain index? Okay, so you have this list and we want to append element 99 at index 2. Yeah, then you can simply use the insert method again. We have the index 2 and element 99. And if you print list, we get the list with the element 99 at position 2. So, and then of course all subsequent elements will be shifted by one position. It has also constant runtime complexity because the list is based on arrays, so we can quickly go to a certain position in the list in constant runtime, and then we just have to do some work there. So basically, if you have to, if you look at this one, so we have a list with 3 elements and they point to each other. And now we want to add one element, then basically we have to remove this, add the element here at this position, and then create a new pointer back. Okay, so therefore it's 2 operations, constant number of operations, no matter how large the list is. Okay, and what if you want to, is the append method thread safe? And it is thread safe if you use the CPython implementation. So what does it mean thread safe? It means that if you have multiple threads who in parallel want to access the list and change the list content using the append operation, for example, then it's perfectly valid, it's possible. Why? Because the CPython implementation uses a global interpreter log, which means that all operations that are defined in the CPython library are atomic. Okay, so if one thread has the log on one operation, it executes one operation, then no other CPython operation will be allowed to run on the same virtual machine on which Python runs. Okay, so therefore this operation, it will just first terminate, and only then we will have some content switches, which means that another thread takes over the resources, but only after the operation has already terminated. So therefore each CPython operation is an atomic operation and cannot be interrupted, and therefore we don't have any race conditions within this. I mean, even if the append operation itself consists of multiple operations, like changing a pointer, changing the array size or so internally, it is one atomic operation for you as a programmer. So you can assume it's an atomic operation. Okay, so therefore it's thread safe. Multiple threads can use it at the same time, and there won't be any race condition or so. Good. So I think this was everything that I wanted to show you. Actually, this was everything I wanted to show you in this video. Good. Thanks for listening, and see you in the next video. Bye.